All right, everyone, welcome. Today, we're going to take a guided tour through the world of network design. We're going to get a handle on the fundamental layouts, or topologies, that connect our entire digital world. I mean, really think about it. The last time you were in an office or maybe a school library, you see dozens of computers, printers, servers, all working together seamlessly. How are they all arranged to communicate so effectively? Well, the answer lies in something called network topology. So what exactly is network topology? To put it simply, it's the map. It's the blueprint. It's how we arrange all those different nodes, the computers, printers, and servers, so that they can actually talk to each other. Okay, now here's where it's really interesting, because there's a key distinction we need to make. We have the physical topology, which is literally where the computers and cables are located in a room. You can think of it as the network's floor plan. But then there's the logical topology. And that's all about how the data actually travels from point A to point B. It's the path the information takes, which can be completely different from the physical layout. So let's start our tour with the most straightforward design out there, the bus topology. This one's really the foundation, and you'll see how other designs kind of evolved from this basic idea. As you can see, in a bus topology, every single device connects to one common central cable. We call it the backbone. When one computer sends a message, it travels along this cable in both directions, which means every other computer on the network sees it. This was pretty common back in the day in smaller offices. So the key thing to understand here is the trade-off. The big advantage? Cost. It's cheap because you only need one main cable. It's also great for a temporary setup. But, and this is a big but, the disadvantages are significant. If that main backbone cable fails, the entire network just goes down. And because every computer sees all the data, there's basically zero security. Next up, we've got the ring topology. And you can probably picture this pretty easily. Just imagine taking that bus design and connecting the two ends to form a continuous loop. In a ring, every node has exactly two neighbors. It's a peer-to-peer setup, so there's no central server calling the shots. Data typically flows in just one direction, hopping from one computer to the next and so on until it gets where it's going. So how does a ring network avoid total chaos? Well, it uses this really clever system called token passing. A special data packet, the token, is always circulating around the ring. A computer can only send data if it's holding the token. Once it's done, it just passes the token to its neighbor. It's a very organized, orderly way to manage communication. Now, while the ring does offer better performance than a bus and gives every node a fair shot to transmit, it shares a huge weakness. Since data only flows in one direction, if just one link or one computer in that ring fails, the entire loop is broken. The whole network goes down. That's a massive single point of failure. Okay, let's move on to the most common topology you'll find today, the star. This one takes a much more centralized approach. In fact, if you have a Wi-Fi router at home, you're basically using a form of star topology right now. So in a star topology, instead of everyone connecting to a shared cable, every single device connects directly to a central hub or a switch. All the traffic, every piece of data sent from one computer to another has to pass right through this central device. The benefits here are huge. It's easy to add new computers, and you can manage the whole network from one central point. If one computer's cable fails, it doesn't affect anyone else, but it introduces a new and very important vulnerability, the central hub itself. And right here, this is the star's Achilles heel. If that central hub fails for any reason, the entire network is dead in the water. Everything depends on that one central device, making it the ultimate single point of failure. All right, so we've gone from a single point of failure to, well, almost no points of failure. Let's look at the most robust and complex design there is, the mesh topology. The idea behind a full mesh is simple but extreme. Every single node is connected directly to every other node. This creates this incredible web of redundant paths. The internet itself is a massive, complex mesh network, which is why if one route goes down, your data can almost always find another way to get there. But all that robustness comes at a seriously steep price. I mean, look at this. To connect just 10 computers in a full mesh, you'd need 45 individual cables. As you can imagine, the complexity and the cost just skyrocket very, very quickly. So the bottom line is this massive trade-off. On one hand, mesh is incredibly reliable and fault-tolerant. But on the other, it is wildly expensive and becomes completely impractical for most large networks. You can see why it's used for critical things like the internet, but not typically in your local office.
Okay, so we've seen these pure designs, but the real world is often a bit messier. And that brings us to our final stop, the hybrid topology.
So take a look at this. What are we even seeing here? There's a bus backbone with a star network branching off one side, and maybe there's even a ring on the other. What do you call this?
This is a hybrid topology, and it's exactly what it sounds like, a combination of two or more different designs. This is the practical solution for most large organizations. It lets them mix and match, using the best features of each topology exactly where they make the most sense.
Which brings us to our final question. After touring the bus, the ring, the star, and the mesh, which one is the best? Well, the truth is, there is no single best answer. The ideal choice always depends on the specific needs of the network. What's the budget? How critical is reliability? How much does it need to scale? In the end, the art of network design isn't about finding the best topology. It's about choosing the right one for the job.